Hey everybody, I want to do a few examples on proving trig identities, and basically what you're trying to do is work out this little puzzle where the left-hand side is going to equal the right-hand side. So a lot of times I'm going to put, looking at example 1 here, to verify this, I kind of put a line there because you can't really cross the line. It's not like you're adding and subtracting things to both sides. The left-hand side stays on its side, the right-hand side stays on that side. It's kind of like they're not friends, right? So we've got to simplify the left and we've got to simplify the right. Well, here's what I know. The right-hand side, well, guess what? It's already simplified. It equals 1. So to verify an identity, that's all you've got to do. Prove the left-hand side equals the right-hand side. So it would be helpful to have your card with all of those identities in front of you. So looking at 1 over secant squared x. Well, 1 over secant squared x is the same as cosine squared x. And then 1 over cosecant squared x is the same as sine squared x. Well, let's see here. Cosine squared x plus sine squared x, well, that is a Pythagorean identity, and we know that is 1. So 1 equals 1. Yes, we have verified it. The left-hand side equals the right-hand side. And guys, that's really all there is to it. The good news is sometimes there's just, one way to get there, and other times there's multiple ways to get there. Let me show you an example of the multiple ways to get there. Example 2, if I have cosine squared x plus tangent squared x times cosine squared x, does it equal 1? All right, well, I like to put my line there. Here's what I see. On that left-hand side, each term has a cosine squared x. I'm going to go ahead and factor out a cosine squared x. And then if I factor that out of each term, I have 1 plus tangent squared x. All right, so I know that 1 plus tangent squared x is equal to the secant squared x. So if I have cosine squared x times secant squared x, well, let's see, what's secant squared x? That's the same as 1 over cosine squared x, and that times cosine squared, well, those are reciprocals of each other, so that equals 1. So I have 1, and then I'm just going to bring down this 1. 1 equals 1. Left-hand side equals the right-hand side. Okay, so that's one possibility. Another possibility, you might have noticed that the tangent squared x, well, what do we know about that? Well, we know that it is equal to sine squared x over cosine squared x, and if I multiply by cosine squared x, these cosines cancel. Let me draw my line here. And I got cosine squared x plus sine squared x. Well, what do I know about that? Well, that equals 1. And I'm bringing down that 1. 1 equals 1. Left-hand side equals the right-hand side. Okay? That is your proof that the identities exist, that these are true, when the left-hand side equals the right-hand side. Got a few more examples here for you. Number 3, I got secant squared x minus tangent squared x equals tangent x cotangent x. Well, sometimes I'll just tell you, if you get a little stuck, it's easiest to, my little trick is to change everything to sine and cosines, because that's what we're most familiar with. That's what we use a lot of. So secant squared x, let's use that trick. Well, let me draw my line here. So not a straight line, but it's a line just the same. Secant squared x is 1 over cosine squared x minus, let's see, sine squared x is the same, or tangent squared x is the same as sine squared x over cosine squared x. Let's see, when we add and subtract fractions, what do we need? Common denominator. Already has it. Awesome. 1 minus sine squared x. Pythagorean identity manipulated. 1 minus sine squared x. Well, that's the same as cosine squared x. So cosine squared x over cosine squared x is 1. There you go. On the right-hand side, looks like I need to simplify that. So tangent of x, well, what is that? That is the sine over the cosine times the cotangent, cosine over the sine. The sines cancel, the cosines cancel, and I get 1. So does 1 equal 1? Well, yes, it does. We have proven that identity. Take a look at number 4. 1 plus tangent squared x over cosecant squared x equals tangent squared x. All right, well, let's see here. 1 plus tangent squared x. That looks familiar. That looks like one of our identities. What is 1 plus tangent squared x? Well, that is secant squared x. So now I have secant squared x over cosecant squared x. Let's see, secant squared is the same as 1 over cosine squared x divided by, this is 1 over sine squared x, because that's what secant squared x is. Let's see, I'm going to go old school here. 1 over cosine squared x divided by 1 over sine squared x. Well, that's the same as 1 over cosine squared x times the reciprocal. Well, that is sine squared x over cosine squared x. Extend my line here. Sine squared over cosine squared is tangent squared. And what's the right-hand side? Well, it's great. It's tangent squared. So notice we also don't just have to have the 1 equals 1. As long as your left-hand side equals with your right-hand side, you're good. You've proven it. Okay? Let's do a few more examples. I think I have a total of 8 maybe. All right, take a look at number 5. You got secant of x over sine of x minus sine x over cosine x equals cotangent x. Okay, well, let's see. What is the secant? That is 1 over the cosine. So this is going to end up being 1 over cosine x sine x minus, and I have sine x over cosine x. And I'm trying to get it to equal the cotangent of x. All right, well, let's see here. Let me get a different color real quick. When I'm subtracting fractions, I've got to have a common denominator. Common denominator here is cosine x sine x. So that means I need a sine of x here on the top and the bottom. So that gives me 1 over cosine x sine x minus, well, sine x times sine x is sine squared x over that denominator. Notice we now have a common denominator. And that common denominator is cosine x sine x. On the top, I got 1 minus sine squared. That looks like Pythagorean identity manipulated. So what is 1 minus sine squared x? Well, that is cosine squared x. So now I have cosine squared x over cosine x sine x. Let's see. A cosine of x cancels with a cosine of x. That gives me cosine x over sine x. All right, let's see. What is the cotangent? Cotangent is cosine over sine. Notice left-hand side equals right-hand side. Okay, here's another one. Tangent squared x minus sine squared x equals tangent squared times the sine squared. Okay, let's see. I think since I see tangents and sines, I'm going to go ahead and manipulate this and put it all in sines and cosines. So tangent squared x is sine squared over cosine squared, and that is minus sine squared. And this on the right-hand side is sine squared x over cosine squared x times sine squared x. Okay, well, let's see. What does that equal to? That is a sine to the 4th x over cosine squared x. All right, let's see what we can do on that left-hand side. So notice I did a little to the right, a little to the left. I need a common denominator. Grab a different color here. That common denominator is cosine squared x. All right, so it's all over the same denominator. Cosine squared x, since I'm subtracting fractions. I've got sine squared x minus sine squared cosine squared. I notice on that top part in that numerator, I can factor out a sine squared. And in the parentheses, I have 1 minus cosine squared. And then I have sine squared, and 1 minus cosine squared is sine squared, because that's your Pythagorean identity, over cosine squared x. And sine squared times sine squared is sine to the 4th over cosine squared x. Well, that's exactly what I have on this right-hand side. So I have proven it. Left-hand side equals the right-hand side. All right, another example. I have tangent x plus cotangent x equals secant x times cosecant x. Let's see. I'm going to go ahead and put them in sines and cosines, see what happens. Let me draw my line. I have tangent of x. That's the same as sine x over cosine x plus cotangent of x. Well, that is cosine x over sine x. Okay, and on the right-hand side, let's see. A secant is 1 over the cosine times cosecant is 1 over the sine. So that gives me on the right-hand side 1 over cosine x sine x. That looks pretty simplified to me. Let's work a little bit on the left here. I'm adding fractions. In order to add fractions, I need a common denominator. That common denominator is going to be sine x cosine x. So I need to do my multiplication. All right, so I got sine x times sine x, that is sine squared x over, let's go cosine x sine x, and then plus on the right-hand part of this, cosine times cosine, cosine squared, and then I've got cosine x sine x. Keep in mind you can multiply in either order. That's why the sine of x times cosine of x is the same as cosine of x times sine of x. Now I got my common denominator here, cosine x sine x, and on the top I got sine squared plus cosine squared because I made like denominators. Well, Pythagorean identity, sine squared plus cosine squared, 1. That's 1 over cosine x sine x. Well, interesting enough, that's what the right-hand side equals. So notice we're just trying to find those pieces of the puzzles in order to prove these identities, where the left-hand side equals the right-hand side. All right, one last one. All right, I have 1 over sine x minus 1 plus 1 over, or not sine x, secant x minus 1 plus 1 over secant x plus 1 equals 2 cotangent cosecant. All right, let me get my line here. I'm going to work a little on the right-hand side. It looks like the simplest of the two. So I have 2 times cotangent is the same as cosine x over sine x, and cosecant is 1 over the sine. Okay, so let's see, that simplifies. Top is 2 cosine x, and on the bottom is sine squared x. All right, let's leave that for a little while. Let's go to the left here. I have 1 over, so it looks like by grouping symbols, that secant x minus 1 is a group, and then secant x plus 1 is a group. So with that, I need a common denominator. So that common denominator, that looks like I need to multiply here by secant x plus 1 on the top and the bottom. And on the right-hand side, I need to multiply by secant x minus 1, the top and the bottom. Yep, that's what it looks like. Okay, so that means that my common denominator is going to be secant x minus 1 times secant x plus 1. And on the top, I have secant x plus 1 plus secant x minus 1. All right, well, nice enough. Let's see here. That 1 minus 1 cancels, and I have 2 secant x's over, well, I'm going to go ahead and FOIL the denominator. That's going to be secant squared x minus 1. Okay, well, let's see. Secant squared x minus 1 is the same as tangent squared. All right, well, let's see what we can do here. This is like 2 times secant x times 1 over tangent squared x. I'm just separating them a little bit so I can just kind of see what I'm doing here a little bit. So I have 2 times, let's see, the secant is 1 over the cosine, and 1 over tangent squared, well, that's the same as cotangent squared, which is cosine squared x over sine squared x. Okay, 1 cosine cancels with 1 cosine. So now I have 2 cosine x over sine squared. Well, that's great because look what I've got here on the right. That's a 2 cosine x over sine squared x. Left-hand side equals the right-hand side. So hope that helps you a little bit with trying to prove your trig identities. Make sure, again, keep that, that trig formula sheet handy.